Ocean current shifts modify global weather stability. How moving water across the planet quietly regulates climate patterns. Why oceans control more than just water. When people think about weather, they often focus on the atmosphere. Clouds, wind, and temperatures seem like the main drivers. However, the ocean plays an equally important role. Large-scale ocean currents move vast amounts of heat around the planet. These movements influence temperature, rainfall, and storm patterns. Without them, global weather would be far less stable. What ocean currents actually do? Ocean currents are continuous flows of seawater driven by wind, Earth's rotation, and differences in temperature and salinity. Some currents move warm water from the equator toward the poles, while others bring cold water back toward lower latitudes. This circulation redistributes heat across the globe. It prevents extreme temperature differences between regions and supports a more balanced climate system. The concept of heat transport. One of the most important functions of ocean currents is heat transport. Warm water carries energy from regions that receive more sunlight to regions that receive less. For example, currents in the Atlantic help keep parts of Europe warmer than they would otherwise be at that latitude. This process stabilizes temperature patterns and reduces extremes. How shifts in currents affect weather. When ocean currents change in strength or direction, the distribution of heat also changes. This can alter atmospheric conditions. Warmer or cooler ocean surfaces influence how air moves above them. This affects wind patterns, precipitation, and storm formation. Even small changes in currents can lead to noticeable differences in regional weather. Examples of large-scale ocean changes. Events such as El Niño and La Niña show how powerful these shifts can be. Changes in ocean temperature in the Pacific Ocean can influence weather patterns across continents. These events can lead to increased rainfall in some regions and drought in others. They demonstrate how interconnected ocean and atmospheric systems are. The role of deep ocean circulation. In addition to surface currents, there is a deeper system known as thermaline circulation. This system is driven by differences in temperature and salinity, causing water to sink and rise in different parts of the ocean. It acts like a global conveyor belt, moving water over long distances. This process plays a key role in long-term climate regulation. Why stability depends on balance. The stability of global weather depends on the balance of these ocean systems. If currents slow down or shift significantly, the balance of heat distribution changes. This can lead to more extreme weather patterns. Regions may experience unusual temperature changes, altered rainfall, or increased variability. Human influence on ocean systems. Human activity can affect ocean currents indirectly. Changes in global temperature can alter water density and circulation patterns. Melting ice, for example, adds fresh water to the ocean, which can influence salinity and flow. While these effects are complex, they highlight how sensitive ocean systems are to change. What this means for climate understanding. Studying ocean currents is essential for understanding global climate. Weather patterns are not only driven by the atmosphere, but by interactions between the ocean and air. Accurate climate models must include these systems to predict future changes. This makes ocean research a key part of climate science. Final thoughts. Ocean current shifts play a major role in shaping global weather stability. By redistributing heat and interacting with atmospheric systems, they help maintain balance across the planet. When these currents change, the effects can be widespread and significant. Understanding this connection reveals how closely linked Earth's systems are, and how changes in one part can influence the whole.